Aggregate gradation significantly influence the concrete strength and durability. Our AI-based platform intelligently calculates the right balance of fine and coarse aggregate based on the structural component type, workability requirement, and pouring method. These ensure a mix that is stronger, more durable, and cost-efficient. To study the influence of aggregate gradation on concrete strengths, using this machine, we will perform compressive strength and flexural strength tests. We have collected representative samples of both fine and coarse aggregate from a local ready-mix concrete plant with a maximum aggregate size of 9 mm. To evaluate the particle size distribution, we have performed a comprehensive sieve analysis. Using our AI-based platform, the optimal percentage of fine and coarse aggregate that was calculated to match the ideal gradation curve, ensuring mix efficiency and optimize the performance.
Our AI platform has classified aggregate gradation into 2 main areas and 5 distinct zones, each tailored for specific concrete applications. The graph shows 2 AI-defined gradation areas, guiding optimal aggregate selection for each application.
3 mixes were designed to follow the optimal gradation curves A, B, and C using our AI platform. In parallel, we also prepared 3 control mixes that did not follow the optimal gradation precisely. The fresh concrete done properly through on cubic and crease samples. Identical conditions, all the samples kept on cubic cabinets with temperature of 15 degrees and humidity of 75. After completing 28 days of curing, now we have samples consist of crease and cubic samples. For testing, we use new testing designed for compressive strength and flexural strength testing of concrete, mortar, and cement base. Nevertheless, notice that since our concrete mix contains aggregates with a maximum size of 9 mm, this machine is fully suitable to perform the test. Otherwise, we should follow a standard size for the samples as well as performing the test with a machine with more capacity, similar to the one behind me. Before running the test, we should adjust the setting of machine. First of all, we should define either this is a flexural or compressive strength test. Once you click on this icon, as you can see, there are two options, flexural or compression. Now we select the compression. Then we should define the sample features, including either is a cube or beam or other shapes. Dimension and the area is calculated by the machine itself. Brace rate type either is a load or a stress. The test parameters including test number, so we can define the name for the test, the number for the test, maximum load, failure threshold. The failure detection, as you can see, it's set on 10 kN, so we approve the default value. You can click on the device setting. So the language device mode, as you can see, is set on automatic. We can adjust the units. The graph features, once the setting is done, we can set on the test screen. Now we should properly position the specimen in the frame using the meter. We can precisely make sure that the specimen is properly positioned. After adjusting the setting, now we can run the test. Now we are running the test. As you can see, this box shows the load, unit kilonewton, and this box shows the calculated stress. And here we have the loading rate, that it's 0.11 megapascal per second. And here we have the curves, that vertical axis we have load and horizontal axis we have time with the unit of seconds. So this specimen failed at 4.4 kilonewton.
Optimal gradation improved flexural strength in all cases. The well-graded mix, curve B, showed the highest strength, confirming its superior performance. Compressive strength tests showed similar results. Mixes, following optimal gradation, achieved better strength performance.